Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So we're going to start the first session in the morning, which is about democratizing semantics for the scientists. And the first talk is given by Joël Sac. And you may want to repronounce your name.
That sounds correct to me. So, good morning. I was having lunch yesterday with Andrea and Kevin, and I said, well, I need to go and prepare my slides. And they were surprised. They said, but your talk isn't until tomorrow morning. And I said, but that's impossible. My flight home to Toronto is tomorrow morning. My talk is this afternoon. But they were right, and I didn't realize the schedule had changed. So it turns out I do have time to give my talk. No, my flight remains, so I'll have to leave immediately afterwards. So please note my email address if you want to follow up on anything, since I won't be around for the coffee break. I'm going to talk about work primarily done as part of the Spire project. Spire was a 5-year NSF project, 2 computer science departments, 2 biology departments, NASA Goddard Space Flight Center that's always looking for new uses for the remote sensing data, and the National Biological Information Infrastructure of USGS. Spire is, I guess, over, but some of these we're still doing the work, and these collaborations remain. In particular, we're still working with Jim Quinn's group at UC Davis and Mike Frame's group at NBII. So, let's see. This is I guess the system concept that we want to build towards. Global human sensor net, a data stream that can be mined for species of interest, as well as anomalies, and which supports drilling down on observations to see what relevant related data already exists in the knowledge base. So before I get back to this, I'm going to give a little bit of background on Spire and some of the, I guess, tools that we throw into the jambalaya to try to enable this system concept. So it's a semantic web. Oh yes, so Spire was about building semantic web prototypes for biodiversity and biocomplexity informatics with the focus on invasive species, which, by the way, do more economic damage than all other natural disasters combined. So we experimented with a lot of different approaches to ontology development, from the ridiculously complex to the ridiculously simple. An example of the former are these ontologies designed by Rich Williams, who was working half time on Spire and half time on Seek before he was poached by Microsoft in Cambridge. So I have his permission to describe his ontologies as a glorious failure. They were, in a sense, strong computer scientist, strong biologist, was the perfect person to be writing these ontologies, and they're an intellectual tour de force of owl modeling and of ecological understanding, but they've proved to be pretty useless for doing data integration. Not useless to Rich, mind you. They drive his webs on the web, food web simulations, but too complicated for everybody else to use. And this sort of goes down to very, very lightweight ontologies that we've developed. And I guess the punchline here is that we're very much into some of these buzzwords that have appeared in the last couple of years, like schema last or schema later, the idea that the schema is what you have left over after you've populated the instance data. Schema is data too, or schema is just data. Interoperability through simplicity. Ethan is the backbone ontology of all of our work. Evolutionary trees and natural history ontology. So there are phylogenetic tree representations for about 350,000 species, plus for 3,000 animal species, more detailed natural history data. So I think, in fact, there are so including lifestyle and some both qualitative and quantitative data. Well, so if you traveled here by plane, you might have seen these great HSBC ads. The world would be a boring place if everybody shared the same point of view. And this is sort of the high-level concept that we want to engender with our ontologies, is enabling different views on the same underlying data. And I can't prove to you that we did this in the time I have. But if you talk to me during coffee, I can show you what I mean by that. Right. So this is an invasive species scenario. You have an ecosystem. Let's see, and an invader shows up, and you want to know, well, what niche is the invader going to play in the host ecosystem? And this is a problem because there are only on the order of hundreds of empirical food web studies in the U.S. It's very time consuming. You have to catch all the fish in the lake and empty their stomachs and see what they've been eating. So there is a need to sort of build a down and dirty food web for a species list, and we did this using an existing database of trophic links and doing some taxonomic reasoning based on phylogenetic similarity to infer new trophic links. So Alvis has three components: the species list constructor. You click on an area, you get the species list. Then the food web constructor. So we see here that in fact Nile tilapia is going to be competing for food with the cute ostracods. And then everything that's part of the ostracod food web is also going to be affected. So the food web generates the possible links and gives you the sort of certainty index, and there are different parameters that can be tuned in the prediction. But then the third tool in the suite is the evidence provider, where you drill down and you see the evidence for and against a particular inferred trophic link. And this sort of represented maybe a shift in our thinking of the semantic web, from the semantic web providing answers to the semantic web provides evidence for and against an assertion. So that generates some data. Of course, as we saw in one of the tutorials, biologists love spreadsheets. Everybody loves spreadsheets. So we need a way to get data out of spreadsheets and into RDF. A lot of these tools existed from the very beginning of RDF, spreadsheet to RDF tools. Lushan, who we hope is going to show up for his talk at the end of this session, developed, I think, the best one, RDF 123, which takes a far more allows far more flexibility in the shape of the schema that's assumed, and what's more, it's so not only does it allow more than just a star-shaped schema where every column represents a class and where every column represents a property and every row represents a class. It is available as a web service, so that the spreadsheet that's online, so the web service takes as input the URL of the online spreadsheet, and then the map itself can either be embedded in the spreadsheet, or it can also be a separate input to the web service. You can have multiple maps on the same spreadsheet, and then it produces the RDF. So you don't end up with, I guess you obviate the need for data dumps, and you don't have stale data. The RDF is generated on the fly on HTTP request. The map, the map. It's an N3 file that maps the spreadsheet cells to RDF classes and instances. So this is neat. This is an example of, I guess, RDF 123 at work. We got this data from EPA. This is benthic macroinvertebrate data in North Carolina. And then it is, you can see, we put it into this linked data browser. And that is the URL of the web service with then the URL of the data and the URL of the map. So I guess this is my sort of shout out to linked data, that 10 years ago this, I guess, is a GIS application, and 5 years ago a Google Maps mashup, and now the browser itself does the mashup, which is neat. And the way it does this is because we use these canonical namespaces. You see the geo namespace for Latin long, the DC namespace for time elements. So in the early days, and even today, there's a lot of talk about creating upper-level ontologies as a means of semantic mediation. And we've been arguing for, I guess, standard lower-level ontologies. And we think that more can be achieved through, more integration is achieved through working from the bottom and working from the top. Okay, so that's data. Those are some ontologies, instance data, and means of generating further instance data. The two main integration projects that we had were Swoogle, Google for the semantic web, where we tried our hardest to attract Google's attention, and we still haven't received a lawyer's letter from them. Swoogle finds ontologies and instance data, ranks them according to an onto-rank algorithm, iterative, similar to PageRank, tries to make a guess as to the importance of a document on the semantic web based on link structure. It calculates a variety of metadata, and this is the only slide I'll show on this, but it's been very useful for studying the structure of the semantic web. And Li Ding, who developed this, didn't do his thesis on Swoogle itself, but rather what he was able to determine about how the semantic web is being used through the use of Swoogle. So that's cool. We can find the data. And early on, one of the biologists said, well, what if... we had this. So then we had this triple shop, the shopping cart metaphor, that you find the data and then you check it out. So you select the data, the ontologies and the instance data that you want, and then you click checkout, and it loads it into Redland, and then you can start querying it. But then the question was, well, what if you don't know what data you want? I mean, shouldn't the data come from the query, and shouldn't the query, in a sense, predate the data? So the idea of triple shop is that you issue a query. And you leave out the from clause, and then triple shop goes to Swoogle and gathers data that it thinks will be useful in answering the query based on terms in the query, and then allows you, then comes back with a suggested data set that you can further tweak and tag and save, etc., before running the query on it. Now, you also have a number of output options. So, we talked a lot about, well, we have to get spreadsheet data onto the semantic web, but since so much computation is done in spreadsheets, we thought it was important to also get the semantic web back into a spreadsheet, so you can get the results back as a spreadsheet. Okay, so that's sort of some of the basic infrastructure that we had going on when we started experimenting with semantic ecoblogging. And the idea is that these ecoblogs were popping up all over the place. Both professional biologists and amateur nature lovers were going on hikes and reporting their findings. And some of these observations are potentially important parts of the ecological record. So you might want to say, well, what was the earliest sighting of a particular life cycle event? Or what was the northernmost sighting of a particular invasive species? Cold is a barrier to the northward expansion of so many invasives, because the larvae of many beetles can't survive the winter. In the last few years, we're seeing a lot more in Canada, what used to be only seen in Michigan, particularly the emerald ash borer. So we created this Firefox plugin that lets you that generates an OWL record from a blog post, and we started using it, and some of our friends started using it. But we have this. We store the OWL on our server, and so we're able to see who's been using our plugin. And we were nicely surprised to see that some people that we didn't even know who they were downloading it and using it. And I like this guy. He works. We talked with him after. He works for DreamWorks, and he's into mushrooms. And this is the link to the OWL record of his blog posts. So we experimented with this 3 years ago, 2.5 years ago, in the first annual Blogger BioBlitz. A guy in the States, well, we're in the States, a guy had an idea to coordinate eco-bloggers throughout the world into participating into doing a biodiversity inventory of some area near where they live at the same time. So a BioBlitz is a 24-hour inventory of all living things in a given area. Historically, I guess has been an outreach tool, but increasingly the data itself is seen to be important because, especially if it's done every year, it sort of gives a snapshot of change over time. So we had 1,200 observations, some of them natively in OWL, some of them converted via RDF123. That's, of course, a tiny data set, especially compared to some of what we've seen at this meeting. But it was enough. It was sort of grist for the mill, and it didn't sit alone. It sat on top of everything else that the natural history databases, the food web data, etc., that we already had, and allowed us to start playing with triple shop, saying, well, find all observations that are of concern to U.S. Fish, that would be of concern to the U.S. Fish and Wildlife Service for one reason or another, and we come back with 57 observations. So that was sort of the where I left off in North Carolina 2 years ago. How much time do I have for? Okay. All right. So since then, we thought, well, the Firefox plugin is neat, but it's still too difficult. People want to make their observations, report their observations in situ. They don't want to have to come home and report them. So we ported Spotter to the Android phone. So now it uploads the photo to the user's Flickr account, creates an RDF record of the data, and generates links between the picture and the RDF record in both directions. And of course, all the metadata is there on the phone. So all the user has to do is type in the identification. And if he doesn't know the identification, he can say request identification. It goes to a crowdsourcing tool, and then people can request, show me all unidentified butterflies. If that happens to be their field of expertise. What we want to do with this, of course, is allow the user. I mean, our lab also does a lot of work in mobile computing and ubiquitous computing, profile modeling, and so we want users to be able to store their profile of what they're interested in, so that they can be alerted when they are in an area where there are potential observations that they might be interested in making. So the example I give here, you have entered the High Park Black Oak Savanna. Here's a list of endangered plants in the area and a field guide for their identification. Obviously, to do this, we have to incorporate easy access to electronic field guides, identification keys, observation protocols. But those are all things that can be pushed onto the phone based on minimal RDF reasoning, either on board or with the back-end server. But already, though, I mean, who blogs anymore? Anyway, there was a meeting in London this summer, eBiosphere, large biodiversity informatics meeting, and we entered the biodiversity informatics challenge, trying to display this global human sensor net concept. And we had observations coming in that we were displaying on screens in the conference hall, and trying to I guess mine in real time. And we got some cool observations from Ottawa, from the conference itself. These were school children in France. Had some stunning observations. Oh, this is timed. The coolest activity was Steve Young in Arlington was twittering all of his observations. So these were some of the things that they found: invasive plants, invasive animals. They were looking for a particular salamander, which they were happy to find. If any of you know Bill Sontag from EPA, here he is in a death struggle with English ivy. And of course the tweets were very easy to parse, and so all of this data was in RDF, and we could query it. Now, this raises some questions, though. We were suggesting a canonical tweet format to make the tweets easy to parse. But is that really necessary? I mean, there is a next month is the TADWIG conference, Biodiversity Information Standards. But in parallel to the standards activity, there have been people, in particular John Pickering of DiscoverLife.org, who have said, well, we don't need no standards. We can just sort of apply a bunch of shallow NLP heuristics onto the data. We know what it is. We know there's going to be a location. We know there's going to be a timestamp. We know there's going to be a species identification. I mean, it's basic metadata. And that's enough to be able to pull out the metadata without standards. We also experimented with nano formats, which is kind of a compromise. Of course, the hashtag is the most famous Twitter nano format, but we were experimenting with the geo/ nano format to identify a location. So I guess it's a compromise in the sense that you would have the geo/ that lets you know that whatever follows is a location. It could be a lat long, it could be a city name, a place name, etc. Right. So here's one of our colleagues one of Jim Quinn's students in California has recently put up the California Roadkill observation system, and this has captured the public imagination. And in a month, they have thousands of roadkill observations. But some of the feedback they have is that people want to be able to make them, to have an app for reporting on their mobile and not have to wait till they're home. And this would also make it easier because then they wouldn't have to record the location. The mobile would know that. So we talked about sort of porting this to a mobile app, but it raises the question, well, couldn't we just use Twitter to report the roadkill? And then that sort of leads to another question: how much custom development do we need of mobile reporting apps? And there's been a lot of development in citizen science in the last few years, and observational biology in general on mobile apps. In a lot of cases, the infrastructure is provided by social networking tools, by Web 2.0 tools, and in a lot of cases, no development is necessary. Simply use cases built around Twitter. An example of this is Encyclopedia of Life, which uses Flickr for their image inventory. And other groups had spent years developing image catalogs, and I think EOL very wisely said, well, let's just create an EOL group on Flickr and let Flickr do everything for us. So what else do we want to do? Well, already there are a lot of sites to do crowdsourcing for image identification. What about crowdsourcing for data collection? So we're experimenting with a wiki where scientists can advertise their data requirements, saying, well, I need these sorts of observations from this area. And you've seen this if anybody's done geocaching, that you can sort of look up an area and say, well, who has left geocaches in the place where I'm going? So our idea is that the telephone will interact with the knowledge base, and again, you'll get an alert that says, well, you're entering Shenandoah Park, and there's this guy in Maryland who needs data from Shenandoah Park, and maybe you can be on the lookout, and here's an observation protocol. This also will tie in to something that's important in citizen science, which is verification. If you can send out alerts to all of your trusted observers that are within an area of a given observation, you can have some sort of data quality and assurance attached to the data. So one of the outcomes of eBiosphere was, I guess, the nascence of a citizen science, global citizen science community of practice. And this goal, I guess, of a global ecology of human and software services to support requests for data, collection of data, integration of data, querying of data. The idea of an annual, loosely coordinated International Week of Citizen Science, with maybe the first one timed to coincide with next year's International Year of Biodiversity. So on our end, to support this, we're planning on trying to stuff everything we know about biodiversity into a triple store. And sort of a back of the envelope calculation shows that we can do that with maybe 50 billion triples. So we're experimenting with OpenLink Virtuoso and Franz Allegro Graph. Allegro Graph is cool because it has pretty advanced support for geospatial reasoning, I think more than any other triple store. And then, so what are we putting in here? Well, obviously biodiversity occurrence records from GBIF, biodiversity inventories of the world's protected areas, shapefiles for protected areas, shapefiles for countries and regions, food webs, species profiles, conservation status, invasiveness status. This will all be available to support citizen science activity, to interpret and add context to observations, and of course it's a test bed for social and semantic computing. So if you want to participate, please do. If you have data to contribute, please do. If you have test cases to contribute, maybe that's even more important. You know, the sort of the discrete charm of the semantic web is that it can, in theory, respond to ad hoc queries a lot faster than a more architected database system. You know, being able to respond to use cases as they come up is an important metric of the success of the system. We have some ideas of what we want to do, some integration experiments, updating Elvis to study extinction patterns in the Sierra Nevada, some experiments with biotic indicators, but again, feel free to suggest further ones. So this is I guess a plug for the Phyloinformatics Vocamp being held with Tadwig next month in Montpellier. In theory, the Vocamp is more of a hackathon than a Vocamp, and it's phylogenetics, taxonomy, genomics, and although the call for participation is closed, I'm sure that if one or two people were to want to participate with some of the amazing technology that, especially in genomics and bioinformatics, that I've seen the last couple of days, the organizers would be open to that. And if you can't make it to Montpellier, I think it would be neat to participate remotely and sort of have the core hackathon team in France, and then also maybe some other hackathon support groups around the world supplying maybe some of the computation necessary to do some of the hacking in France. So there are a lot of pitches. On the wiki, you can suggest a project to work on during the 4-day hackathon, and you can see what's already been suggested. You could offer your own suggestion. One that I want to be able to do is integrate genomics data with biodiversity occurrence data. And in theory, it shouldn't be too hard to be able to query biodiversity occurrence data based on genomic properties. But it hasn't been done yet. I think it would be a neat outcome. Well, so, Tim Finan likes to make the point that in the early days of AI, some assumptions were made about what would be hard and what would be easy. And it turns out a lot of things that we thought would be hard, like playing chess, turn out to be easy, and things that should have been easy, like navigating a room, turn out to be hard. And I think that the same thing has happened in the semantic web, that if you look at the vision papers from the turn of the millennium, people were saying, well, with the semantic web, we'll be able to do all these great sort of mashups and a lot of those turned out to be possible just with open APIs and Web 2.0. On the other hand, some of the other vision, like is the ozone hole getting bigger or smaller, where you have to know the semantics of scientific instruments, and you have to know how to do the proper data manipulation, and turn out to be perhaps. It's hard to know. I mean, as the last talk said, some things are hard to describe formally, and hard to formalize an algorithm for answering. So I think that there's going to be a lot more sort of blended social semantic computing combinations. For example, of Cindy Parr at EOL has an idea for a blended computer vision system with a mechanical Turk component also for image identification. That some of it is done by the computer, some by the human. And I guess the sort of superstar students that did all of this and my colleagues and NSF and NBII, and also I'm very grateful to Microsoft. I think it's great that they both fund and host this meeting. And some references. Questions?
Thank you.
Yes?
Some of the things that you were talking about would make biologists turn into their tombs or whatever, such as, asking for untrained people to go around identifying species and then connecting them and so on. Do you have any thoughts on that?
A lot. One, I don't think it would make biologists roll in their graves because citizen science has always been an important part of biology. One factoid is that the majority of invasives are first cited by amateurs. There's a lot of different levels of citizen science activity. There are people who train volunteers for invasive species monitoring efforts, invasive species eradication efforts. Obviously, it's important that you're pulling out the right plant. And there are mechanisms that can be put in place, as I was sort of hinting at, for validation and assurance. Obviously, that's maybe the biggest issue, right? In citizen science is data quality. So that's.
There have actually been quite a few studies that show that citizen science data is very nearly as good as professional collected data when the protocols are created in a thoughtful fashion.
Mm-hmm.
Deborah, I saw you looking kind of skeptical when I said, well, we'll never be able to answer if the ozone hole is getting bigger or smaller on the semantic web. So maybe, if you want to prove us wrong on that point, that would be cool.
Actually, I think that we can make an impact on that. I think that's such a general question that the trick is to break it down into smaller questions where we can have more contribution and where more semi-automated methods can make more difference.
Yeah, but I will say that when Peter was presenting your work in Glasgow at Practical Semantic Astronomy, I did think at the time, wow, he's sort of giving the lie to some of the skepticism that that I was espousing about the possibilities of finely grained semantic data choreography, I guess. So,
You may have covered this because I missed the beginning of the talk, I'm sorry. But it's related to the earlier question. Have you thought about incorporating trust networks using both and adding levels of trust for particular observers? And you break them higher because...
yeah, in fact, what I didn't say is that we sort of see this, the citizen science data as a test bed for. I mean, our lab also does a lot of work on distributed trust and models for propagating trust, and usually it's synthetic data that's used for that. And we thought, well, this would be a neat way to have some real data that we could apply those models on. So yes.
That would definitely be valued. I've talked to a number of people running projects that say they have various heuristics and mechanisms that they try to use to identify who's the most reliable. And
Yeah.
so that would definitely be
I mean, I'll tell you another dream that I have. When we have a project funded by the Air Force Intelligence Lab on assured information sharing, and the Air Force isn't giving us any data. They're just saying, oh, use like baseball statistics and try to predict who's going to win the World Series or something. So my thought is that so many problems in assured information sharing show up in citizen science that it would be neat if this could be our test data for the intelligence project, and then the Air Force will be funding the biodiversity research. That would be neat. Okay, if anybody wants to share a cab to the airport, let me know. Thank you for your attention.